Adsorption of acetic acid on charcoal. This experiment helps us to validate Freundlich adsorption isotherm, which reveals the relation between intensity of adsorption and mass of adsorbent. Here, acetic acid is adsorbate and charcoal is adsorbent. So, materials and operators given in this video, and the procedure is the weighed charcoal shifted into standard flasks, numbered standard flasks, and the standard flask containing charcoal filled with 0.1 m acetic acid. And the standard flask, after filling acetic acid, is shaken well and allowed to stand. After standing for few hours, these flasks are filtered into labeled or numbered boiling test tubes. The filtered acetic acid is taken and added with phenolphthalein and titrated against 0.1 m NaOH. By getting burette readings V1, V2, V3, V4, V5, one can calculate the concentration of remaining acetic acid present in the filtrate. So, before that, the acetic acid is standardized by titrating with sodium hydroxide, 0.1 m sodium hydroxide solution. The burette reading is considered as VI. Here VI means initial volume. So these are the flasks on stand. After that, they filtered into the numbered boiling test tubes. So after filtration completed, acetic acid collected from each boiling test tube and titrated with 1 m sodium, 0.1 m sodium hydroxide solution. Now the students are doing that. The filtration is going on. After filtration, they are collecting the filtrate, means acetic acid present in the boiling test tube, which were obtained from the flask after filtration. Now they are titrating in order to get V1, V2, V3, V4, V5, which are previously told. The volume of NaOH required to neutralize the remaining acetic acid. So, and finally, they found initial volume of acetic acid, that means pure acetic acid is taken for the titration. So, after completion of all titrations, that means from all boiling test tubes, the readings was noted, and from the difference between initial volume and V1 and initial volume and V2 initial volume and V3 initial volume and V4 initial volume and V5. Then one can calculate the concentrations of acetic acid present in the standard flask. So, by finding the concentrations of acetic acid remains, one can calculate the weight of acetic acid lost, and that means the weight of acetic acid adsorbed on the surface of charcoal. By getting the weight of acetic acid adsorbed on the surface of charcoal, it is considered as X. If it is divided by the mass of charcoal added into standard flask by standard addition method, the efficiency or the intensity of adsorption can be derived. After deriving intensity of adsorption, that means X by M, one can plot a graph by taking X by M value on y-axis, that means intensity of adsorption on y-axis, and mass of charcoal taken in the flask on x-axis. So, that can help us to validate Freundlich adsorption isotherm. So, by doing this experiment, the validation of Freundlich adsorption isotherm can be done. This experiment was performed by first year BSc chemistry major students of this college. So, and finally, they have proved that the Freundlich adsorption isotherm has justification. After completion of the experiment, one can conclude that intensity of adsorption is always inversely proportional to mass of charcoal. As mass of charcoal increases, intensity of adsorption, that means X by M value, decreases. Being here in X by M ratio, M is mass of charcoal, X is acetic acid adsorbed. So, being the mass of charcoal is in the place of denominator, as mass of charcoal increases, X by M value, that means intensity of adsorption, decreases. Now, calculations are going on. Thank you for watching.